So the very first thing we're going to talk about when it comes to hydraulics and pneumatics is safety. Why? Because all of this fluid is under extremely high pressure. What that kind of means is that high pressure anything can actually enter your skin if you have a cut or an abrasion and cause some very, very severe issues. So three kinds of hazards. You have burns from hot, high pressure spray, bruises, cuts, or abrasions from flailing hydraulic or pneumatic lines, and an injection of fluid into the skin. That particular one always worries me the most because if it's hydraulic fluid, what are you dealing with? Huh? Thank you, chemicals. You're dealing with chemicals. You're not just dealing with petroleum. Petroleum alone, oil alone, is bad enough. But what do we do to oil to make it into, let's say, transmission fluid versus power steering fluid? What's the difference? It's all in the what? Not so much viscosity. The chemicals. It's the chemicals that make it thicker, thinner. It's the chemicals that give it different properties, kind of like gasoline. What do they put in gasoline in the high dollar brands? They put additives in it, right? Same thing for any oils that are ever used in anything. They have specific additives to help either thicken it, thin it, whatever they need it to do. That gets in your body and it can make you extremely ill. I can tell you for a good example, if you ever get into things like having to change out transmission fluid or power steering fluid, brake fluid, you get that on you and you don't kind of like try and get it off sooner rather than later, it can actually make you physically ill. Now think about that for a minute. So, and that's just getting it on you and it's slowly absorbing through your skin. We're not talking if you have a cut or something on your skin and you actually get it sprayed into that, especially at super high pressure, that's going to deliver a very high dose that can actually make you extremely ill. That's why you want to make sure you do not have pressure on your lines when you're connecting or disconnecting anything. Okay? Air in your bloodstream is bad enough. Dissolved air is already in your bloodstream. And you can, air is one of those things that you just don't want excessive in your bloodstream because if your body can't break it down fast enough, you're going to be hurting. Anybody ever heard of the bends? You get that when you're scuba diving. What happens is that you naturally have nitrogen in your blood. And when you're scuba diving, all the nitrogen starts to come, it starts dissolving better into your blood, I guess you could say. That's why they try and pull as much nitrogen out of the air that you're breathing if you do a deep dive. Because if you come up too fast, you have what's called the bends. It's where dissolved airs, like oxygen, nitrogen, things like that, come out of dissolution and basically you get air bubbles in your bloodstream. It's very painful and it can kill you. And I'm honest to God, I'm not sure about all the mechanics behind it, but yeah, I learned how to dive. Never actually gone out deep diving, but yeah. Something that you definitely do not want. You don't want excessive air in your bloodstream. It does not bode well for anybody. So safe fluid power system performance requires general maintenance. You need to make sure that high pressure and low pressure fluid components and relief valves are installed as safety measures. It's just like electricity. See, the whole thing about it is that a lot of the time people don't respect anything that's got power to it. You know what I mean? Kind of like electricity. How many of y'all seriously actually respect electricity for what it is? Those of you that have ever been in a class of mine, right? Or been shocked before. There's all sorts of stuff that happens with electricity, but we tend to treat it like a toy, right? Hey, look at how fast this spark comes out. Look at, anybody remembers those little spark bulbs that you had the little, dang it, you had the glass globe over it, you had all the purple lightning that was sitting in it. It was a little toy that you just like, you put your finger on it, all the lightning got attracted to your finger. There's all sorts of toys that involve lightning and how fascinating it is. Yeah, up until you start playing with it and decide, oh wait, no, that's not a good idea. Because it actually will hurt you. And it's the same thing with fluid power. You don't think that it can hurt you, but you give it enough time and enough energy, it'll make it hurt. Think about a pressure washer. That's your very basic handheld pressure washer. How many of y'all have ever used one? What do those do? They shoot pressurized water, but what kind of damage can they do? This is just water. Huh? If you don't control your pressure and stay far enough back, it can strip paint off his car. It strips dirt out of concrete and can actually blast its way through concrete if you leave it there long enough. It can, we don't even want to talk about what it can do to dirt and trees. And if you really are, I won't say word, nope. If you are seriously not smart enough not to move your skin out of the way, it can strip the skin off you. And that's water. That's just high pressurized water. And it's that dangerous. Think about that for a minute. That's not a good thing to have if you don't respect it. Right? And again, how many of y'all have ever done some really stupid things with a pressure washer? Everybody needs to raise their hand because I think we've all gotten a hold of a pressure washer and went, wee, look, I'm gonna write my name with it. Huh? I have to. Now, in my defense, we had drained our pond and it was covered in algae, and I was trying to pressure wash the algae off. It was still kind of fun to write my name in the algae. But respect any and all things that have high pressure or high electricity to them, because it can come back and bite you if you are not careful. I mean, most of it is not the Hollywood style of, oh, you put this with this and it's going to create an explosion. No, most of the time it's just going to be, oh, you just fried yourself. It's not geysers of oil that blast up out of a hose. It's more like you get this big leak and, you lay in it for long enough or you sit in it for long enough while you're messing with brakes or transmission. It'll make you sick because it can absorb through your skin. It's like anything else. So periodically checking for leaks and worn hoses. Don't ever do it with your hands and your fingers, because that's asking for trouble. That's going to get you bit by something, right? Think about that for a minute. Yes, you should check for fluid leaks and worn hoses, but you want to make sure you do it properly, and many places have a specific way they wish you would check it. If it's pneumatic lines, what's the best way to check it? Can't see air. You can hear it. Soapy water. Exactly. Something very simple. It's soapy water. It's the way you check for leaks on a tire. Y'all know that, right? If you're ever looking for a leaky tire, you've got a little puncture in your tire. Spray soapy water on it, what's it do? It's gonna blow bubbles. Keep contaminants from hydraulic oil and replace filters periodically. That's what you're supposed to do within your car, right? So why would you treat a pneumatic system at work any different than you do your car? Every X amount of miles or X amount of months, you need to change your filters because otherwise what happens? Everything gets gunked up, breaks down, and just. And if you really don't replace your filters periodically, there have been stories that have been told to me about how a filter, most of these filters are paper. The ones in your car especially, they're like some sort of high grade paper. And if you don't change it out after a while, that bond between the paper and that keeps it in there, apparently that can break down. And you end up with that all in your engine. Not a good idea, not a good thing, and that would be a nightmare to clean out. No, I had a good friend of mine tell me that that had happened to her. And at which point I sat there and went, yeah, don't think I want to do that. So, and you should coat cylinder rods with protective lubricants. So one of the good things about hydraulics is also kind of a good thing, that's the bad thing about pneumatics, and that's the fact that hydraulics can actually self-lubricate to some degree. Now, that's not to say you should not periodically go check your cylinders, and if they look a little dry, you probably should add a little bit of lubricant to them. Because what would happen if you don't? They'll stick, they'll seize. If nothing else, they can also start getting worn spots and start bringing contaminants into the cylinder. And then you have a really bad cascading problem. The problem with pneumatics is that we try and keep any and all moisture out of pneumatics. So what do we have to do with them? What do we add to those kind of systems, you think? You add boilers. You have the ability to add what's called an oiler. So what it is it sprays a microfine mist into the air that is in the lines, and a microfine mist of oil. So whenever it's going through all the lines, what does it do? Lubricates it, huh? Mm-hmm. You have to periodically top it off. But yeah, it's an automatic mister. So basically, it just. Did any of you ever use the things that connect to your garden hose that fertilize your yard? Y'all know what I'm talking about? Yeah. But what it's supposed to do is fertilize your yard, just because what it does is it puts pressure into where the fertilizer is, and that churns it into the water, and then the water picks it up and pushes it out the end of the hose. Okay? It's similar to that. What happens is that as the air is moving through your unit, we have filters in it so that it pulls out any dust particulates. Now, if it's too small for the filter to pick up, that is what it is. Also, we're trying to pull out any water, because what do we have a very bunch of, especially during the summer here in Alabama? Humidity. Don't you love it? Makes people's hair frizzy. It makes it feel like 5 times hotter around here. Basically, it makes you feel like you're in a sauna on the sun, right? So what we have to do here in Alabama, and the South especially, I mean, Mississippi, Alabama, Georgia, Florida, Louisiana, any place where you have a lot of water, you have a lot of humidity. The problem with humidity is that it causes what if it gets into your metal and plastic lines? It's going to cause a lot of what? Dry rotting and rust. It causes a lot of dry rot and rust. What do we not want? Either of those. So we try our best here to keep fluid out of the lines, because it just is not good for anything you've got, right? So part of what we have to do is we pull the water out, which dries out the air. That causes its own issues, right? We try and pull out the particulate, which dries out the air even more. So what we have to do is turn around and put oil or some sort of something back in there so that we don't end up with stripping out any oil that's already in your system. And by that I mean most of these components come with some form of oil already a part of it, right? Because that's factory setup. If you buy anything that's kind of hydraulic or pneumatic, it's already got some oil on the parts that move, just like anything else you buy that moves. They add just little dollops of oil to help keep everything lubricated. Well, eventually you do, if you dry it out too much, you strip it of all the lubricant. So you have to add more to it. Problem with that is that by adding that, you're also adding chemicals to the system so that if that hose comes loose, not only do you have the dust particulate that's left over, you end up with that oil that's in the hose, right? Now if that gets in your skin or that gets into whatever, that's not going to feel too good. And there's not really a good way to find it because it's not like it leaves a giant oily residue. It's not giant drops of it. It's a micro mist. Like you never even know it's there. So that's why you need to make sure you cut off all lines before and depressurize your system before you work on it. Because if you don't, it can mess you up. It can cause a lot of problems. Okay? So fluid power. This is the use of a confined fluid flowing under pressure to transmit power from one place to another. It has no fixed shape and yields easily to external pressure. Liquid and gas are primarily used in industry. Now, when it talks about gas, what is the most common one we use as far as gases go? Do we use specialty or we just use basic air? We use basic air. Why? Because it's cheap. All you gotta do is have the compressor suck it in, press it down, send it on. And then at the end of the day, what can you do with the rest of that air? We can re-release it into the wild from whence it came. Only it's generally cleaner than whenever it went in. Generally. So the main advantage of fluid power of our electricity is that actuators can be stalled without damage. If you do that with electricity, you are probably going to do what? Probably going to burn something up, right? Tear up your motors, something. The actuators can be linear or rotary, but the speed is very simple to control because all you got to do is control the pressure and the speed of which fluid flows into that cylinder. We have the ability of force multiplication. That's how you lift a car. Think about that for a second. Your car weighs at minimum 2 tons, yeah? Or a ton, right? 2,000 pounds. I don't care how much or little is put on a car. Between the engine and the body itself, it's weighed in right around a ton, 2,000 pounds, right? And or more. You, the simple human, weighing somewhere, we'll say 300 pounds or less. Okay? That way I don't insult anybody or make anybody feel bad. Okay? You're picking up something that weighs 2 tons with a car jack that weighs probably, what, 5 pounds? Through force multiplication. That's why a car jack is, especially the ones you find in your car itself, that always has to be the worst thing you have to use, right? Because how many times do you have to jack it to get like an inch? I'm talking just the bare edge to get that tire out. Nah, I've sat there for 20 minutes pumping on that thing trying to get it Some you got to turn. But again, it's force multiplication. Because you, the human that weighs like less than a tenth of the car, are able to pick up said car so you can put a tire on it. Think about that for a minute. It's kind of cool, right? So that's the force multiplication. You, the human, can pick up a car or a truck or an SUV. Personally, I thought it was really funny in that video that you got this little girl in a white dress standing there pumping on that thing. That was funny. Because I don't know about anybody that would have white clothes on trying to mess with a vehicle. It's too nasty to do it. I mean, come on. Fast actuator direction. And that is very true. The fact of the matter is you can switch fluid flow direction in the blink of an eye, and it really does not bother these systems very much. High level of power through simple means is probably the most truthful thing here. Hydraulics have shaped this earth since time began. Just through water. You have eaten away, water has eaten away at this earth for millions of years. You've taken mountains and turned them into hills over time. Think about that for a minute. You take giant pieces of rock and basically melt them away through water. That's kind of a humbling thought to that. And the fact that fluid is that powerful and that we use it daily, and we don't hardly even realize it. But fluid has its dangers too. What happens if you get air in a hydraulic line? Let's say your brake line. You're not going to be braking anytime soon, right? What do you have to do every time you work on your brakes? You got to bleed them. You got to bleed them to use them, because otherwise you are going to be up a creek. Just to put it nicely. Yeah. It means there's actually a tool that's called the brake bleeder. What it does is it pulls any air out of the line by pulling fluid out of the line first. You really don't want fluid in you want fluid only in the line, because if you put air in the line, air compresses. You can take a bottle full of air and you can crunch it, right? What happens if you had that same bottle full of fluid of whatever your choice is and you try to crush it? It won't do it. And that's the problem with brakes. If you don't bleed your brakes, air crushes. Fluid does not. That's why you can go through the air so much faster than you can go through any kind of fluid. I don't care if it's water, I don't care if it's quicksand. That is the problem with having to do your own brakes. If you've never had to change your own brakes, you probably have never seen the process. I've helped my father change my brakes, his brakes, mom's brakes, my sister's. Met several times on his trucks. And that's something you have to do, because while you're changing it, you can get air in the line. And that air's no good. So you have to have what's called a brake bleeder. Generally, you're using it to suck any and all fluid, air, and all that kind of stuff, anything excess, while you're stomping the brakes several times to try and pull any air that might be in it out, because otherwise it's not going to be a good day for you if you go off with that, because you might try and hit the brakes, but it's going to be like the brakes are not there. So whereas generally you get feedback from your brakes as you press them, because they're pressing back. Nope, you just be pressing on it and not a whole lot will happen. Yep. So, yeah, you can do a high level of power through very simple means, but you got to be careful of those simple means and make sure you do it right. Because if you do it wrong, things happen. And there's two areas of fluid power. You have hydraulics, which we've kind of talked a little bit about, and pneumatics. So hydraulics is literally liquid. Pneumatics is air. Why do we call air a fluid? see air move and be poured. You are actually holding it over like a tub. You can sit there and pull out the ice, and then you have this cloud of vapor. You can actually look like you're actually pouring clouds into a tub, since carbon dioxide is so heavy. Now, when it comes to pneumatics, can you use something besides air? You can use nitrogen. You can use what? Helium? Helium's used. Huh? Nitrogen, hydrogen, helium. Carbon dioxide is used. I mean, how else would you make dry ice? There's a lot of different components that you can use. We generally use air because it's easy. But there are some systems. So if you ever go to a hospital, what's one of the systems that some people end up hooked up to? Oxygen. Thank you. You're hooked up to oxygen. Why? Because some people cannot obtain enough oxygen while they breathe. So you flood their system with oxygen. Well, has to come from somewhere, right? You got to pump it up to the rooms and everything else. So it's easier to produce straight line motions with fluid power. It really is. Transmit equivalent power to a much smaller space. It's safer. Why is it safer? This is one of those times I wish I had my home drill, because I've got a nice little power drill, and if you've ever really looked at the motor as you spin that sucker, what does it do? Not just spins, it sparks. Bad thing about electricity is it can throw some sparks out. Why is that unsafe? Well, if you're in a flammable environment or an explosive environment that may or may not take a little bit of spark to set it off, that's not something you want to use around that. Or if you're working around fluids that are flammable, not such a good thing to work around.
Why is he creating sparks?
Huh?
I said, why is he creating sparks? And what does he create?
If you hadn't asked me that, I knew it. Huh? It's the motor that creates it. I'm trying to remember why, but my brain just. You ever had those days where your brain just says, nope, information not available. Try it back tomorrow. But it has to do with the motor and the friction of the motor. A lot of motors have what are called brushes inside them. So when they spin, those brushes create the electricity, but they can also create sparks and arcs. That's part of the problem with electricity, is because when you spin motors and stuff, or you can have a little bit too much friction, you can have problems with that. The other reason is that electricity gets really hot. It can overheat. It can definitely overheat. It's got plenty of problems. Fluid is simple to control: direction, speed, force, and torque. Pressure can be held constant without applying additional amounts of energy. Think about this. How long can a car be jacked up? Well, I'll say jacked up. If you've ever seen a car lift, how long can that car lift stay up?
Till you lay it down?
Till you're ready to let it down. You have to apply more force periodically? No, it just stays there. That's the great thing about fluid power. You can't do that so much with electricity. That's all done with hydraulics. Now, pneumatics, you might have to go back and add a little air periodically, because air does compress over time. And the longer you leave it up, the more problem it would have because of all the heavy weight on it. But with hydraulics, it just sits there and goes, yeah, what else you got? You want to add more weight here? Come on. It's like that buddy at the gym that's sitting there going, I need more weight. I need more weight. No, this is too light. Come on, add some more. Hydraulics has very little limits.
side of
99% of what we use as hydraulic fluid is petroleum based. So that's all oil based. Some of it's just over processed and has additives to it to make it work for certain things. It depends upon what you need as far as viscosity and if you ever watch the commercials and believe them, supposedly they can help break down crud that's in your system. If you ever watch about the soap cleaner or whatever crap that they add to gasoline for the really high dollar stuff, that right now probably is about $4 a gallon instead of the $3 that everybody's having to pay for basic. But I digress. I don't think it's going down right now. Yeah, that's all it's done. They actually just added more gas tax to our already inflating prices. So thank you, government. Power is much easier and more cost effective in applications that require both pressure and position control. And that is, again, true. Just like I said, you're looking at a car lift. That right there should tell you everything you need to know about hydraulics. You can do so much with it. You can leave that up there 24/7, 365, and it does not bother it, right? It just sits there and goes, okay, and I'm still here. Nope, still here. You can walk under it, you can walk through it, you can sit there and jump in the car, and it just stays where it's at. That is the good thing about fluid power. You really cannot see the same results with pneumatics. Well, you can with pneumatics somewhat, but again, pneumatics will compress over time. It's electricity that cannot do that. Why? Because you'd burn out the motors if you did not have some mechanical way to stop it. Does that make sense? If you don't have some mechanical way to stop it, it sits there and can burn out the motor very quickly. Motors don't like to be stalled. Really don't. So the actuator advantages is that you have a device that converts pressure into motion. You have compact and high energy potential. Like I said, 1 inch on piston with hydraulics. It does a lot more than you can get out of pneumatics or electricity. They can be stalled for extended periods of time. Lord, I can't keep tripping over my tongue today. Best thing is they are instantly reversible. So if you sit there and go, oh wait, wrong car, and you're already like 3 inches off the ground, you can sit there and drop it back and go get the next car. Right? It takes nothing. Think about what we were seeing in that video. Not only can it move up, but it can move down, and it does it at a very easy rate without having problems with it. If you start a motor and then switch it from reverse to forward, or forward to reverse, you keep doing that back and forth, what are you going to do to that motor? You're going to fry it. You're going to fry it like a Thanksgiving turkey. Think about that for a minute. But yet with a pneumatic or hydraulic, you can do that endlessly and it never will stop, feel anything, just sit there and go, okay, so backwards, forwards, and it bothers it not at all. Okay. They are instantly reversible, infinitely reversible, as long as you are trying to do both at the same time. And you can, like I told you a minute ago, you can vary the speed as long as you are varying either the speed of the pressure fill up or you're varying the ability for it to fill up. We'll get into that later. And of course, with any industry, you always have what? You got the organization of standards. Now, why like all the standards. The standard is evil. Why do we actually like standards? Anybody know? Thank you. It means that you get a 3/4 screw with a 3/4 screw no matter who you get it from. Used to, everything was handmade. All right? And if you've ever seen handmade nails, are any two ever completely the same? No. Could they have been? No. Why? Because you are dealing with a human error, and there's space for that, but you're also dealing with a process that is not standardized. When you standardize a process, you allow for less variation, yes. But sometimes, in a lot of ways, that less variation is a good thing. It means that if I've got a bolt that is a M16, I can take any M16 ratchet and socket, and I can move that bolt. It doesn't matter who made it, where it's made, how it's made, none of that. It doesn't matter. I can move that bolt. So while standards are kind of one of those, everybody hates them because it just means that there's no variation. Just look at how many cars look alike today. How many of you have ever kind of walked up to a car going, that's my car? And you look at it a minute later, you're like, no, that is not my car. That looks a lot like my car, but that is not my car. It's like look around and you're like, okay, every car looks ever loving the same, right? We've all had that happen. Why? Because it seems like every time you turn around, they're all just copying each other. Oh, this gets the best. It comes with this gets the best wind resistance. This gives the best this, that, and another. What it is you're slowly seeing things having become standardized. Why? Because A, makes manufacturing easy and you can get their parts a lot more easily, right? Does that make sense? But B, it means that doesn't matter who you go to, just all starts coming down to preference. Most of the time, the only difference is what? Not so much the exterior, but the interior. And that's where your true divisions come in. Standards they're a good thing and a bad thing because standards mean that you get rid of the variety, but the good thing is that you get rid of the variety. Just depends on what you're talking about, right? Does that make sense to everybody? Yeah. Sorry to go off on that tangent, but it's kind of like OSHA. Everybody always groans when you say OSHA. Why? Because everybody assumes OSHA is the devil. No, OSHA is the people that make sure that you can go to work and they have to provide you steel-toed boots and safety glasses and a hard hat. They're the ones that mean they have to provide that. If you don't, then you get trouble. So it's one of those things of I always like to try and put out the good things that these people do. Because we all sit there looking and go, oh Lord, they're coming. Oh no. The world is coming to an end because these people are going to be here. No, it's actually not that terrible. Because it very well could mean that something that is really dangerous is going to end up finally fixed. So, looking at the Standards Committee, you have the National Fluid Power Association, the American Society for Testing and Materials, the Society of Automotive Engineers, the American National Standards Institute, ANSI's a lot of places, by the way, and the International Standards Organization. Okay? And these people are all overseers who try and make sure that everybody's conforming to the right standards. Now, that's not to say you can't get odd standards going. That just means it's a little bit less tricky to, if I order a 1-inch piston, I'm going to get a 1-inch piston. I'm not going to get a 1 3/4 of an inch or a 1 1/4 inch. I'm going to get what I ask for. I'm going to get what I need. And I can replace it no matter which manufacturer I go to. Make sense? So you have the National Fluid Power Association. They just dictate cylinder sizes, mounting styles. And their whole mission is to cooperate with joint industry committees and conferences where such activities are intended to advance the performance and application of fluid power products by means of better materials, designs, where practical standardization. In other words, they're the people that are going, oh, innovation. Hey, you know what? Let's put that into practice. Because sometimes small innovations can lead to larger innovations, right? You go from something like a piece of leather to these rubber O-rings that are common and very standard with just about everything you buy these days, right? Maybe they might find a better material. One of the ways that they apply most of them now, especially if you're talking about gaskets, is what? Huh? Well, a lot of the gaskets today are done by robots. Why? Well, because of precision. Less room for error. Yeah, because they can go back to the same spot within a hair's width. Think about that. Huh? A lot better than human. And it means that there are less mistakes. Everything is sealed better. That's why engines are so much more efficient today than they've ever been. Because we have so many different checks and balances. And a lot of things like that can actually be attributed to fluid power. Because how does an internal combustion engine work? A lot of it's through fluid power. Here's what nobody ever thinks about. You're using gasoline, that's a liquid, and it creates exhaust, which is air. So you have literally got fluid power running through almost every system you've got. Yeah, I think all of y'all are sitting here like, wait, what? Because the way an engine works, especially the internal combustion engine, is that it sprays fuel and mixes it with air. Once it lights that off, it takes the air that is pushed out, sends it out the exhaust. And that's a very simplified version of that, but different gaskets and different modes of all this are how all of this has been set up. Yep. Yep. So that's the National Fluid Power Association. You have the American Society for Testing and Materials. This is a voluntary standards development organization. So a lot of these people keep coming back to, we're trying to put in standards. Now, why is the implementation of standards a good thing? It's because you're not talking so much to the individual companies about this as you're talking to the people they work with. So let's say you are in automation or might not use your company. All right, let's say you're Rosa, right? So Rosa needs to automate something. And by standardizing what everybody has, it levels the playing field for all companies that are doing automation. Why? Because no matter who you go to, they have access to the same materials. And that allows for what? Thank you. It allows for competition between companies. So by standardizing so much of this, it's allowed for more competition in the marketplace. Now I don't have just one company that I can go to automate everything, and then they are the only people I can go to because they're the only ones that I can get anything from. It means that I can look at 20 different automation companies and say, oh, these people have the best price, but These guys are local and they can come help me if my machine breaks. It's opened up a lot of competition. And like I said, everybody groans when you hear standards. It does a lot of good. So you get people that create these standards, and those standards become the trusted everything. Okay? So the American Society for Testing and Materials is the world trusted source for technical standards for materials, products, systems, and services. So if you would prescribe to them, not only is your company good here in America, worldwide. You can ship whatever you've got to anybody you need to. They have an important role in the information infrastructure that guides design, manufacturing, and trade in the global economy. So they're just kind of, they help keep the global economy rolling, I guess you could say. The Society of Automotive Engineers. You have 7,000 committee members that maintain 8,300 technical standards and related documents. So them maintaining something says what? Are standards stagnant? No, they're not. Standards are not stagnant. Standards constantly change and evolve. So if you go back to what they were talking about, how leather was one of the initial things that they used as a sealant. Well, if that's the standard for 50 years, and somebody comes along and says, oh, wait, I cut this piece of rubber, and it works better. The standards organization can sit there and go, oh, do some testing, do this, that, and another. You know what? This actually is a better material. Leather is no more. Let's go strictly with this piece of rubber. That's what happens every day, all day. Okay? And so the largest developer of technical standards for land, sea, air, and space. Everybody is served by these people. ANSI is the American National Standards Institute, and they have their fingers in a lot of pies too, because if you've ever taken robotics, they're mentioned there too, right? This is a private nonprofit organization that administers and coordinates the U.S. Voluntary Standardization and Conformity Assessment System. Notice that it says the voluntary standardization. Why is standardization something that would be voluntary? Because some people actually still prefer the handmade nails. However, that means that if that company goes out of business that handmade your nails, you're going to have a hard time finding somebody that can replace that nail if it gets broken. Just going to point that out. So there is good and bad things about standardization. If you go with not standardizing, you do have things that become more unique. However, it means that it's a lot harder to repair at the end. Look at something like a Tesla. Yeah, I'm going to bring them into this. Tesla is the only company that's putting out these smart electric vehicles, right? It is unique, mainly onto Tesla. Yeah? So what would be the problem with that? They're the only ones fixing them and have parts for them. Can I go to Advanced Auto and get any parts for a Tesla? No. You got to go straight to the dealership. So while it's great that it's such a unique product, the downside is nobody knows how to fix these things. You cannot take them to your local mechanic and sit there and say, hey, yeah, this thing's got this bug going on. You think you can fix it? Sure, we'll have it done in a day or so. You can do that with any car today, except a Tesla. Something to think about. That's a Toyota product. I ain't touching that. That's a totally thing of itself. So it's a voluntary standardization, but if you jump off the beaten path, you're kind of on your own. That is, in and of itself, its own self. ISO is the National Standards Organization, and I think they'll probably be the last ones, and I'll let y'all go for the day. So ISO is a network of national standards institutes of 146 countries on the basis of one member per country with a central secretary in Geneva, Switzerland, that coordinates the system. These are the world's largest developer of standards, although ISO's principal activity is the development of technical standards. So, just some people to know. And this is where we'll pick up on Wednesday with fluid power systems. If y'all have any questions, y'all can kind of